Good morning, everyone. My name is Sarah Marcotte, and I'm a public engagement specialist here at NASA's Jet Propulsion Laboratory in Pasadena, California. So I want to welcome you to our You've Got Perseverance April student webinar. So housekeeping first, we are recording today's webinar. So students and mission team members, keep your cameras on, but your mic's muted until we either call on you to ask or answer a question later on in our webinar in the Q&A. And you can, to ask your question, you can either use your raise hand icon. You can also put questions into the chat. So we'll be looking at the chat for those questions. Okay, so on behalf of the Perseverance Rover mission, today we are honoring 11 middle and high school students who have shown the qualities of perseverance in their educational journey. So this webinar is not necessarily about getting the best grades. It's having the grit and determination to do your best and always continually improve. So how did we get this idea for these webinars? Well, we decided to make a video so we could ask the country, do you know a student who's got perseverance? So let's watch this video.
NASA wants to know, what does perseverance mean to you? Our Perseverance Mars rover and mission teams already know quite a bit what it means to persevere. We found a way to launch the rover from Earth in the middle of a global pandemic. And since surviving the trickiest Mars landing yet, we've continued to overcome unexpected challenges in day-to-day operations and collecting and storing our first rock samples for future return to Earth. When you set your mind on a goal and stick to it, you can accomplish almost anything. Do you know someone who has perseverance? NASA is looking for nominations of students from around the country who've kept moving forward when the going got tough. The You've Got Perseverance Award highlights the grit and determination of the next generation of explorers. Awardees will get to chat with NASA experts and even get a once-in-a-lifetime personalized message direct from the Perseverance rover on Mars. We can't wait to hear how you've got perseverance.
Okay, so we asked, and people from all over the country nominated the students you'll meet today as students that they were inspired by. So these 11 students each had their own unique stories on how they overcame the challenges this school year and persevered to make the most of their opportunities and to forge their own paths in learning this year. So we are so proud of all of these students. Now, as part of our congratulations, next you're going to hear from members of the Perseverance Rover mission, and you are going to hear about the mission itself. And then later, you're going to get a chance to ask questions. So you're also going to see some personalized messages that have traveled from Earth to Mars and back. I mean, that's a pretty unique thing. So let's go over to mission control. I see we have Nikki Cox, who is our mission lead for the Perseverance rover, and she's going to tell you all about the mission next. So good morning, Nikki.
Good morning. Thank you, Sarah. We are so excited to be here with everyone, and congratulations to the awardees. This is a very exciting day. So we are actually here in Mission Control at the Jet Propulsion Laboratory in Pasadena, California. As she said, my name is Nikki Cox, and I'm one of the mission leads. And the folks you see in the room behind me are some of our team members. And a little bit later, the downlink team will be coming in to assess what happened on the prior sol on Mars. So a Martian day is called a sol, and this is the room where the team will evaluate, did what we hoped happened on Mars on the prior sol actually happen? We also have team members in this building that, again, in a few hours will be here to then plan what the next Sol on Mars will be like. And they'll do that in the room right across the hall. And then we have folks behind us as well who will be planning the next week on Mars. So some of those team members are here with us in person. We also have team members that regularly support us remotely from other countries and other areas around this country. And some of them will even be on the webinar with us today to answer some of your questions. But first, let's start with this video. Gives you a little bit more background on the mission. So Perseverance is NASA's 5th and most advanced rover that we've sent to Mars, and it was designed, built, and tested right here at the Jet Propulsion Laboratory, again in Southern California. We launched in 2020, and then we landed over 2 years ago on February 18th of 2021. So that's more than 2 Earth years ago. We've been exploring Jezero crater ever since, taking images, measuring the weather, and importantly, taking samples. So that's those samples which will help us determine if there was ever life on Mars in the very distant past. To determine something that important, we actually need to bring the samples back. And as you see on your screen, this time we have a partner with us, the Ingenuity mission, the Mars helicopter. And we also evaluate in this room as well how Ingenuity is doing. We've just put 10 samples on Mars, and we're going to be bringing them back in about 10 years. So all of you on this webinar could be involved in that mission, and we hope that you are. So how do we communicate with the rover? We have this graphic that will help. It seems complicated, but it actually is very exciting, and this room is part of what's involved in that. So right now, it is Sol 7:54, and it's the evening on Mars. So we tend to work when the rover is asleep. So the rooms in this building, as well as all of our partners, will think about what we want the rover to do the next day. Then we use our deep space network, which is a series of radio antennas that are around the world, to send those commands to Perseverance. When Perseverance wakes up, it executes those instructions and will drive, take samples, image, all of the things that we've asked it to do. And then in the Martian afternoon, it will send its data up to a number of rovers, a number of orbiters that are circling around Mars that we use they're also doing their own science missions, but they're also relays that help us get the data back from the rover. That data comes back to the Earth, and then we actually repeat the cycle where, again, while Perseverance is sleeping, we will decide as a team what we want the rover to do on the next Sol, and the cycle begins again. So that's what makes this room so exciting, and this building, is because these are the folks that are involved in that. And again, there are folks from around the world that support that. So we also have an ability to put messages inside the sequences that we send to the rover. So this video will show that a bit. So we send our sequences, we build the sequences here at JPL, and we send those to the rover on Mars. It will process them and then send those messages back. And in some cases, we've been able to encode specific messages into the rover, and some of those are the messages from the rover saying, congratulating you on all of the work that you have done. So I think that some of those may, in fact, be ready for us to look at right now. Let me walk over and show them here on the screen. So hopefully you're able to see those. Those are messages from Mars that have your names in them. And we'll show you those messages again in a video. And while we're queuing that up so you can see your messages on the big screen, I'd like to introduce our Deputy Project Manager, Steve Lee, who's with us right now.
Well, hello, everyone. Thanks for joining us, and congratulations on all the awardees for this amazing opportunity to see your names and messages sent to Mars and back. Just wanted to thank you all for all of your great perseverance. You're a real inspiration to everyone here on the entire Mars 2020 team. We really appreciate everything that you've done and the hard work that you do and your ability to overcome obstacles. The name Perseverance for the rover was actually named by a student. It was a contest a few years ago, and students could suggest names from around the country, and the name Perseverance was selected. And boy, did that turn out to be a great name, because during the pandemic, it was a real challenge to finish assembling the spacecraft here at Jet Propulsion Lab and sending it to Kennedy Space Center, doing all final preparations, putting on a rocket and launching it all the way to the Mars while being safe with each other and trying to keep everybody as safe as possible. But the team was able to do that and successfully launched the vehicle, sent it to Mars after about a 9-month cruise, successfully landed on Mars a little more than 2 years ago, and has been, as Nagi said, supporting the exploration of Mars, finding some fantastic, interesting geological sites, sampling a whole series of rocks and putting samples on the ground and carrying some additional samples on board, getting ready to hand those off to future spacecraft, which are in the works right now, that will return those samples, like Nagi said, in about 10 years for detailed analysis on Earth. So we can finally answer the question, was there ever life on Mars? We still don't know the answer to that question, but in the next 10 to 15 years, we'll finally be able to answer that question. So without further ado, let's play your names and messages that were sent 100 million miles to Mars and 100 million miles back at the speed of light.
Now, how cool is that those messages came hundreds of millions of miles? It's longer than my commute in the morning. Oh my goodness. Okay, so thank you so much to Nagi and Steve for those kind thoughts and the messages to and from Earth to Mars. So students, now is your time to ask the people in this room and the people online your questions about Mars. I know a few of you put some questions already in the chat, and then others have the ability to unmute themselves and ask aloud. Now, it's helpful for me if you use the raise hand icon, because then that kind of puts you in a good spot along the top of my screen and I can call on you. And of course, you are talking to people who deal with rovers and Mars and robotics and planetary stuff. So we'll keep our questions, relevant to Mars and the rover, and also about careers, in case any of you are interested in pursuing a career in aerospace or anything like that. So, and also I just wanted to ask, in case we have Timothy or Michaela or Ariane have joined us, if you have, raise your hand icon as well, because I'm going to promote you to panelist, then you'd be able to ask your question aloud. Okay. Oh, good. Look, I'm seeing all sorts of good stuff. So Janani, would you like to ask your questions?
Between the Curiosity rover and the Perseverance rover. Can you tell us about its challenge during the mission and how you persevere?
Okay, Janani, you got cut off a little bit, but I do have your question here. So I'm going to repeat your question that you just asked. So for Perseverance and Ingenuity, can you tell us about a challenge, a specific challenge during the mission and how you persevered?
That's a great question to start with. And we actually have our partners here from the Ingenuity mission. So Harel, would you like to take that question about challenges that we faced on the helicopter?
Absolutely. So I'm Harel Dorr. I'm the Deputy Operations Lead for the Ingenuity helicopter. And midway through our mission, after Ingenuity had already done several flights, we were trying to keep up with the rover as it moved across Jezero Crater. One day we waited for our data to come in from the helicopter, and we saw that although everything was working fine on the rover's side, we didn't get any data from the helicopter, and we were really worried. We weren't sure exactly what happened. And we realized that what occurred was the helicopter's battery was running so low that it actually forgot overnight what time it was. And so we have scheduled times every day for the helicopter to communicate with us. And because it didn't know what time it was communicating at the wrong time of day. So we actually had to set up a long span of time for the rover to listen for the helicopter. And eventually, when the helicopter did wake up, when it thought that it should, the rover and the helicopter were able to communicate, and we were able to keep the mission going, even though it was really scary and we had to try really hard to make sure that things kept working.
Great example of some real-time problem solving right there. And I like that you kind of admitted like, "Phew," it was maybe a little bit scary sometimes when you're operating spacecraft on another planet. However, you figured it out, and that helicopter has made a lot more flights than we expected, hasn't it? And we're coming up maybe on a milestone flight, I hope. Exciting number.
Yes, that's true. Today we're
Yeah.
hoping to upload our 50th flight, which
Yeah.
is a real achievement. We would have been extremely happy just to get one flight. I think 50 flights is more than anyone imagined that we would ever
Right.
get to, and we're so
Oh,
proud.
Yeah, I know. We are really hoping for the best on that, sending our exciting helicopter flying vibes over there 100 million miles. Now, let's see. I see Gershon. Would you like to ask your question?
Yes. My question is it possible for humans to inhabit Mars in the future?
So that's a great question, and one that I think is on all of our minds, especially with us thinking about sending astronauts back to the moon. So there is a hope that after we are able to return to the moon and establish a presence on the moon, that will set the stage for being able to send humans to Mars. And the time frame for that is about the next 10 to 20 years. We expect that it will be an international crew, and our rover missions and the helicopter missions are setting the stage for that by trying to help identify places that might be good for humans to do, for humans to land, to do science, and paving the way by understanding the weather and the environment where the humans might be. So you'll notice that I said again, 10 to 20 years. So we're certainly hoping that students and those of you who are on this call will consider that possibility that you could be involved in that mission to Mars that we hope will happen in about the next 15 to 20 years. So exciting possibilities.
Yeah, it's neat to look so far out into the future, especially when these students are graduating from college or graduate school or wherever their paths might take them. Ajit, would you like to ask your question?
Yeah. So what chemicals and materials did you use to make Ingenuity lightweight enough to fly on Mars?
So that's a great question again about Ingenuity, and Harel, I think I'll go back to you for your thoughts on that about making Ingenuity.
So I am not an expert on the materials and chemicals used to make Ingenuity, but I do know that our rotors, the propellers that we use to fly, were made out of very lightweight carbon fiber materials. And we actually considered using aerogel, which is one of the lightest materials that people have ever made, to insulate our electronics box. And we decided that it was actually too heavy. So instead, we just use carbon dioxide gas in there to keep us nice and warm overnight.
I'm I am amazed that aerogel was too heavy because I have seen it and it's very light. So really important to keep our tiny little helicopter as lightweight as possible to fly in that thin Martian atmosphere. All right, we have another question from Christopher. What is your question today?
A day here is how long on Mars?
How long is a day here compared to a day on Mars? So we have with us one of our engineers who helps us get ready for our shifts, schedules our timing, and helps us know exactly when we need to be at work. So Chris, would you like to answer that question about Mars time versus Earth time? And Chris, I think you're muted. Okay, so we might have a technical difficulty there. So how about if I go over to a member of our training team, Tomas, who's also involved in making sure we all know the environment that we're going to be working in, especially the timing. So over to you, Tomas.
Hi. So correct. The time in Mars is a little different than it's on Earth. So we could say that the time on Mars is 24 hours and 37 minutes. Slightly longer than it's on Earth, but how we have to coordinate for this. So whenever we are scheduling for time on Mars, we have to think about that. So every time we're shifting time, so we have to make sure that everything here we send is corresponding to that time. So yes, that's a great question.
Okay, I see that Alyssa has a question for us.
Hello. So I was wondering how the helicopter works in space, or how it's affected by the difference in gravity compared to Mars and Earth.
So lots of questions on the helicopter today. Do we actually have Josh on the line, or Harel, would you like us to go back to you for this? So lots of questions for Harel, back to you.
Yeah, I don't know if Josh, our operations lead, is on the line. But yeah, so the helicopter faces a lot of challenges to fly on Mars. Not only is the gravity lower, but there's also much, much less air. The atmosphere is about 8% the density of that of Earth, I believe. So we have very large propeller blades that spin very, very fast to try to catch as much of that air and give us as much lift force upwards to get us to fly, even in the really challenging conditions of Mars. So it's a very different problem from flying on Earth, and we had a lot of people working really hard on it to develop this mission.
Excellent, thank you. So a lot of interest in the helicopter, but we love it because it's the first time NASA has ever sent a helicopter to Mars. And of course, we were thrilled that it exceeded our expectations. So let's see, I see Renee Miller, but I know it's not Renee. Did you have Christopher Bailey with you?
This is
right?
Carter Bors.
Oh, great, Carter, sorry, got the name wrong. Carter, you want to ask your question?
Yeah, I was just wondering, wait, can you hear me?
Yep.
Okay, I was just wondering how you get the, like sample data back to Earth, and if you if you bring the actual samples back in the future, how you're gonna do that.
So why don't we start with our one of our sampling engineers who's on the call with us. So Noah, would you like to talk about the data coming back, how we get data back on our S&C activities, and then how we're going to get the tubes back?
Yeah, that's a great question. So we get a lot of data back from Mars. And some of the data that we get back on the samples are actually images to see if we actually got some core inside. We also get a lot of volume measurements on the tubes too. And of course, we work with the scientists to also localize where we got the cores. And to get the samples back on Mars, that's going to be a collaboration with the sample return mission that I'm sure probably Nagin knows more about.
Yeah, so Rick, who's actually our project representative, Rick Welsh, who's one of our project management, one of our project managers, has also been interfacing with Mars Sample Return, the mission that will bring these back. So Rick, would you like to add to that?
Sure, hope everyone can hear me all right. You know, it really is an exciting time because people have been thinking about bringing samples back from Mars for a long time, but now we actually have samples ready. We just got to find a way to pick them up. And so they're working on a mission that will be a lander that we hope to rendezvous with and deliver the samples to. And it actually has a rocket on board. And I guess the picture behind Sarah, if you look at her background, you can actually see a model of that, which would be about a 10-foot tall rocket that would actually blast those samples into orbit around Mars. And then there'd be a separate spacecraft that would be developed jointly with the Europeans that would scoop those samples up and bring them back to Earth. So we hope, you know, in the early 2030s that we may actually get those samples back here on Earth.
Thank you for pointing out my pretty picture, Rick. We just had this made and I was so excited. So I wanted to deploy it, put this big poster up for this webinar today. So you can see some of the future spacecraft that would help in this pretty complicated project to bring our samples back from Mars, including the first rocket launch off another planet, which would be this Mars Ascent Vehicle, and then hitch a ride on an orbiter and fly by Earth. And then the samples would be brought to Earth and scientists all over Earth could study them. So it's an exciting time, and Perseverance is the first leg of that future campaign. So Tammy, let's hear your question today.
So I was wondering about how diverse the NASA work field is, because usually when people think of NASA, they think of like engineers or like people in STEM, and I'm wondering if there's any jobs like that go beyond that or are a little more obscure.
That are a little bit more obscure. Well, we have with us our project manager today, Art Thompson, who is involved in all levels at JPL. And so Art, would you like to take that question?
Sure, that's a very good question. And yes, we, NASA and JPL have a lot of engineers and scientists, but we also have a huge support staff because we can't do this all alone. So we have HR people, we actually have doctors in psychology that help us to understand how much stress we're putting on our teams. We have office managers that we couldn't get the job done without them because they make sure that all the logistics is taken care of for us. So there's a whole gamut of educational backgrounds that support us. And there's even a lot of jobs that you don't actually have to have a college degree to get in. We have technicians that have been working on the spacecraft, both mechanical and electrical and thermally. It's good if you have a STEM background, but you don't have to in order to do that. So if you're interested in pursuing this field and college isn't for you, there are opportunities for you here, and we need everybody to get the job done. No one person or one team does everything here.
Thank you, Art. Might I just add to that, we definitely have artists and designers and graphic designers here. So we definitely have a lot of creative types. I would say that the scientists and engineers are very creative in how they solve some of the challenges with our spacecraft, but we do have creative types who communicate out to the public about what we're doing and do things online or create experiences for people to follow along in all of NASA's missions, whether they're ones on Mars or missions to Jupiter's moon Europa. We have lots of variety of different kinds of jobs. Now, Zanelle, you had sort of a similar question that you put in the chat. Would you like to ask that question aloud?
Yeah, thank you. So are there other rovers from other countries on Mars?
These are such great questions, so diverse about so many different things. And standing next to me again is Steve Lee, our Deputy Project Manager. Steve, would you like to answer about other rovers on Mars?
It's a great question. And in fact, There is another rover on Mars that China successfully landed around the same time as Perseverance, and it did exploration through all of their summer over the winter. Since it's solar powered, it could be that dust accumulation or it got really cold, so it hasn't moved for several months. They haven't made any announcements about what their plans are for it, but it did complete its mission. That's the only other surface mission that other countries have provided. However, as you saw in terms of getting your messages to Mars and back from the surface, there are a number of orbiters around Mars, and those orbiters do all kinds of great science looking at the surface from above and understanding the atmosphere, understanding the geology of Mars all over. And there have been multiple nations that have sent orbiters to Mars successfully. In particular, we have partners with our European Space Agency, and they have orbiters that, in fact, we use for relay that have made great science contribution. And as Rick mentioned, they, in fact, have an orbiter planned that will be supporting the Mars sample return that for the first time will go to Mars and break orbit and come all the way back from Mars and bring those samples back to Earth. But great question, and definitely exploring Mars is an international effort.
Neat. Okay. It looks like the next two questions we have are people have already asked questions, so I want to make sure we don't have any new questions, but there's time. So Gershon, I'll call on you next, and then Janani, you'll get another question as well. So Gershon, what's on your mind?
I was wondering, what's the power source of the Perseverance rover?
Such a good question. And we actually have our team chief from the engineering operations team, who also happens to have been critical in our development, the development of the power system. So Lauren, would you like to take that?
You bet. Yeah. So the rovers, both Curiosity and Perseverance, are nuclear powered. They have what's called a radioisotope thermoelectric generator. It's a mouthful, so we just call it an RTG. And that uses heat from decaying plutonium to generate electricity. So we get about 105, 110 watts of heat or energy rather from that we use to charge our batteries that store up. So it's kind of like your phone. You charge up your phone and then you walk away and use your phone. So we do operate the rover in a similar way. We store up a bunch of energy that slowly from the RTG into our big battery, and then we're able to do more for short times and to using energy from the battery. And while when we sleep, we use less energy, and so we're able to recharge the battery.
Excellent. Thank you, Lauren. Let's see, Janani, you had a question in the chat, or would you like to ask it aloud?
What is different between the Curiosity rover and the Perseverance rover?
Okay, Nagi, the question is, what is the difference between Curiosity and Perseverance?
Well, that's an excellent question. Both are still operating on Mars, and they have different science objectives. So we have a few scientists with us that I will turn that over to. So Emily, would you like to talk about the difference between the Perseverance rover and the Curiosity rover in their objectives?
Sure, thanks, Nikki. So for Perseverance, we're looking for signs of ancient life. That's one of our primary objectives. And a key difference between the two rovers is that they contain different instrument payloads. So that means they have different instruments on board. So some of the instruments may look a little bit similar, but they are quite different. And one instrument that I'm excited about that we have on Perseverance is the Sherlock instrument. And that actually has two components within it. And it has an imager, which is similar to an imager that we had on Curiosity. And then it's also able to look at the minerals and organics and make chemical maps of the rocks that we're looking at. We also landed in 2 different locations, and we're excited to be going up onto the Delta now with Perseverance.
Excellent, thank you. So it's, all of our rover and orbiter and lander missions all feed into each other and build onto each other. And we are getting such an incredibly complete picture of Mars with these many spacecraft that we have sent to the skies above Mars and the lands on Mars. I'm going to take a question from the chat. Carter had asked what the goals or missions NASA is working on.
So what are the different goals that NASA missions are working on? And we have we have a number of our mission leads with us. And so Daniel, would you like to take a shot at that one?
I'm so sorry, Nikki, could you repeat the question?
Yeah, absolutely. So the question was, what are some of the other missions that NASA is working on, and what are some of their other objectives separate from what we're doing on the rovers?
Yeah, that's a great one. So obviously we've got our Mars rovers that are driving around the surface of Mars, and that's excellent. But NASA also has a huge Earth science directorate where we study things that are happening right here at home on our planet. We have a number of Earth orbiting satellites that study climate change. And we also have a bunch of interesting technology development programs, not only to research new technologies for use in space, but also to advance the stuff we do here on Earth. And obviously, in the news lately, we're going back to the moon. So that is a humongous effort that NASA is starting to kick off with some international partners. You may have heard that there's a Canadian astronaut that will be joining 3 Americans to go to the moon next year. So that's all really exciting. We've got a lot more going on than just Mars at the moment.
That is very true. We're a big space agency, and last I checked, there's a lot to explore out there. So many places to go. All right, I see 2 more questions. So Ajit, would you like to ask your question? And then Tammy.
So in all of these Mars missions, have you discovered any minerals or chemical compounds that are not present on Earth that are on Mars?
Great question. So Libby, would you like to take that one as one of our other science experts on the call?
Sure, I can take a stab at that. Hi, my name's Libby. I'm a geologist working on the Mars 2020 mission. And that is a great question because it's one that we're asking ourselves every day or every time we get new data down. For the most part, the minerals that we've seen, the minerals that we've seen so far look familiar to us. So they are the same or similar to minerals we've seen on Earth. And our challenge is to try to understand why and where those minerals are coming from and why they're there. And that's kind of our puzzle. Emily, did you want to comment on maybe some of the non-mineral chemicals that we've seen?
I could comment on some of the minerals as well. So some of the minerals that we've seen on Mars so far, while they are present on Earth, they're not as common as maybe they might be on Mars because Mars is quite dry. And so some of the minerals that we've observed are present, but maybe not stable on Earth because we have water in our atmosphere. So an example of that would be some of the salts that we've seen. And when we're working with salts in the lab here, depending on which lab we're in, they can become hydrated quite quickly. And so because Mars is drier, they're stable in different forms for a longer period of time. And another mineral that we've observed that is present on Earth, but not in as high abundances, is a mineral called magnesite, which is a magnesium carbonate that tends to be, or that is more abundant on Mars than we found on Earth.
Excellent, thank you. Thank you. I love the combination of, sort of mission questions and science questions. It's always fun when we get, a whole variety of neat things to talk about today. Tammy, why don't you ask your second question?
My question's a bit more, I guess, fun you can say. My class recently did like a project kind of
Oh my goodness.
on Mars. So I did the Perseverance rover, and it's kind of how I learned about the You've Got Perseverance thing. And as a treat, we watched the movie The Martian. And I'm wondering more of, do you think that The Martian depicted Mars or NASA or just things in general in an accurate light, or do you have your like quips with it?
So that's a great question that actually comes up fairly frequently. So why don't we have with us one of our tactical uplink leads, Kim Stedman. And so Kim, would you like to talk about how you feel about the movie The Martian?
Well, first of all, I really love that movie, but its depiction of JPL and life at JPL was actually hilarious. Because they had just regular engineers going to the director's office and trying to solve problems with the director. And well, that doesn't happen. And their offices were rather large. And the guy who's a low-level person had a sofa in his office. And most of us have cubicles. So that was hilarious. But a lot of the stuff on Mars was really accurate. And the book, if you ever read the book is also fantastic. So I thought they did a really good job. I think the thing that was the most inaccurate about the book and the movie was that there was enough wind to blow off a piece of, what was it, a satellite dish or something, a communication dish that impaled a human. And even the author has said that was not accurate to Mars. The wind is just not strong enough to do that. But he did that. He made that choice because he didn't want the astronauts' own stupidity to get him stuck on Mars. He wanted it to be something that was outside the astronauts' control. But it's a great movie.
That movie was a lot of fun. And I'm sorry you don't have a couch in your office, Kim. You know, I've got a lounge in mine.
Yeah, no couches in my office.
All right, me neither. All right, we have time for one more question, which we are going to go to Gershon. Gershon, you're going to bring it home for us.
Okay, so is it possible for a rocket to go at the speed of light?
Is it possible for a rocket to go the speed of light? So we have with us some of our downlink team, and the engineer that will be leading the downlink assessment today is Nick Pepper. And you saw him when I showed the messages that came to you. So Nick, would you like to answer that last question for us?
Sure, I can give it a stab. I'm not a physicist, so I'm sure that this is at least, close to correct. But based on our current understanding of physics, special general relativity, and the speed of light as sort of a universal speed limit, it is unlikely or perhaps impossible that a spaceship will ever actually go at the speed of light. But it could get very, 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 very close to the speed of light. So, 99.9% or whatever, if you use some sort of advanced technology, advanced propulsion to achieve that speed. There were all sorts of interesting effects on the people inside and the time that it would take to go from one place to another. Physics sort of breaks down at the upper limits of things like that, at least as far as we understand, but it's all theoretical at this point. So for now, there are missions in far-flung development at NASA to go to Alpha Centauri or some of these, other stars away from us that'll take new and interesting technologies that'll take us further than we've gone before in terms of how fast we can send any kind of object. But we're pretty far away from being able to even get close to the speed of light. I think it'll be a very exciting area in the next maybe 100 years, 200 years. As technology advances to see what we can, push that envelope, but, maybe someday.
Well, that was actually a really neat question to end on, because it was sort of looking farther into the future that perhaps we're getting close to the speed of light. I'm glad I didn't get that question, because I would have been, I don't know. So thank you so much to all of our students for those really amazing, great broad range of questions that we had today. And let me tell you what happens next. So students, check your mail in the next couple of weeks. You will get a personalized certificate with your message sent to you from Mars and the rover. And you'll have a packet with some other cool stuff like a mission pin. So you can feel like you are a member of the mission team. And those of you who are online who may have nominated some of your student awardees, check back for future opportunities next school year for this kind of thing. So you can check our website there or use that short URL, Got Perseverance. And I would like to go back to Steve one more time to maybe show us those messages again. Steve? Steve, you are muted. Love it.
Hi, thanks, Sarah. And congratulations again to all of the awardees. Your stories of perseverance are a real inspiration to us and your schools and your communities and your families. It's just wonderful to see you thrive, and we are so happy to provide this special opportunity for you. Everyone on the flight team, let's give them a round of applause. Good job, everybody. And with that, we will play those messages that have gone all the way to the surface of Mars and back one more time. And congratulations again, and thanks for joining.